Okay, Assalamualaikum warahmatullahi wabarakatuh. Good night, everyone. How are you today? Fine.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Good night.
Good night, Anita.
Okay, thank you, everyone. And let's start about discuss this night. Well, discuss this night. We'll discuss about the material of fluid, and this material of the fluid will be presentation from group 9 and the audience from group 10. And the audience from group 10, there are Winaka Melasari, Vera Yunita, and then Arya Prasetyo. And from group 9, there are Ayamanita Fitria and Mai Anggraini, and then Rizky Pridion. Okay, let's start about the discuss. And for Mai Anggraini, can share screen. Okay, thank you, Maya. And that you are in here can see that this presentation. Yes. Okay, this presentation today about fluid. And the first material of the fluid will be delivered by me. And before that, let me introduce myself. My name is Sanita Fitria, and my student identification number is 2113022018. And I am from Group 9, Class B, Basic Education. And then is fluid. This material is fluid and density of the fluid. Next. So, what is the meaning of the fluid? Do you know? Okay, that fluid is any substance that can flow. The example of the fluid is all water, there are milk, oil, and all liquid, and the air or gas. The example of fluid because that's all can flow. And while of the rocks and the wood and all solid, they are not classified as the fluid because they cannot float. So, a fluid is any substance that can flow. And the next is a fluid divided into two. There are static fluid and there are dynamic fluid. What is the meaning of the static fluid? Static fluid is a fluid that is the stationary phase. The example, the first, water in a bath that is not subject to any force that makes it move. And the second is river water, and the river water has a uniform velocity for each particle. And the second fluid is there are dynamic fluid. So dynamic fluid is the first. Fluid can be a liquid or gas in a motion. And to make it easier to study, the fluid here is the first considered state and has a constant velocity with the time. And the second is incompressible or no change in volume. And the third is not viscous. And the fourth is not turbulent or no cycle. And the our life relate to this dynamic fluid. And the next. So, can you imagine or can you think about the denser of the wood and the iron? Next, Maya. Have you ever compared the weight between wood and iron? I think you are in here have ever compared. Well, the next is back Maya. And well is, can you heavier the wood and the iron? That's the name of the density fluid. We can see from this picture. From this picture, we can see the fluid is have no same. Have you ever compared the weight between wood and the iron? Yes. And When the wood and the iron is not true. When you say that wood then iron is heavier than wood, that's not true because the transfer the iron is denser than wood. Why? Because next, because density of the fluid, we still remember that every object has a different density and is a natural density. And we can see from this picture, and in physics, the measure of density of a homogeneous object is called its density. And the next, from picture. Okay, we can see from these pictures there are have three substance or three the example of the density of the fluid. We can see the density of the fluid is not same, and we can see from that color, the first is yellow, red, and green, and then purple. We can see from this picture the density of the fluid is different from substance. From substance has a different density. And will next is there are density is a measurement of the mass per unit volume of an object. Remember, the density is mass per volume, and the unit is kilogram per meter, and or we can say 10 pangkat 3 gram per centimeter kubik in Indonesian language. And the higher the density of an object, the greater the mass of each volume, and density is used to determine matter. Each substance has a different density, and a substance, regardless of its mass, whatever its volume, will have the same density. Next. Okay, mass of object is aberrant mass when submerged, and their equal is density of water equal volume of object. Next, well, the next is table of the same density. Table of the same density. Yes. Okay. Density of the fluid we can see from this table. There are substance of air, alcohol, wood, and ice, water, aluminium. And this is we can see that density of the air is 1.2, and density of the alcohol is 800, and density of the wood is 300 until 900, and the density of the ice is 920, and the density of the water is 1000. And we can see the density of the substance is different or not same, because density of the substance is the equal from the mass per volume. Okay, the next is state an object in a fluid. There is three states on object in a fluid. The first state is fluid. Okay, the object is called the fluid when the object not completely submerged at the fluid, because density of the object is very low than density of liquid. And the next is okay, the next step an object in a fluid is drift. The object is called drift when the object is completely submerged in the fluid but does not touch the bottom of the fluid. And there are has drift, not the top or not the bottom. and the middle, the object that are in the middle of the fluid, because the density of the object is the same of density of a liquid. And the next is next, Maya. Okay, and the last of state and object in a fluid is the sink. The object is called the sink when the object is completely submerged in the fluid and touch the bottom of the fluid. Touch the bottom, and the object is the position in the bottom of the fluid, because density of the object is very higher than density of the liquid. Okay, I think that's all material about the fluid and the dynamic, the fluid and density of fluid from me, and I give the next material for my friends, Maya Anggraini maybe, or Rizky Fridion.
The next is me.
Yes, so the next material will be delivered by Rizky Fridion. For the Rizky Fridion, this time is yours.
Okay, thanks for your change for me. Before that, Maya, can you share screen? Maya, can you share screen, please? Okay, thanks to Maya. Now I will deliver the material about pressure in fluid. Before that, let me introduce myself. My name is Rizky Fridion. My student identification number is 21130222036. From Faculty Teacher Training and Education with the study program is Physics Education. Okay, next slide. Next slide. Okay. Okay. At the first is I will explain about a fluid pressure. The fluid will exert pressure on a surface area that is in contact with it. Pressure is defined as the force acting on a surface area divided by the force acting on a surface divided by a surface area. Okay. Okay, and with the formula is pressure equal force divided by a surface area, with the pressure is Newton per square meter, force is Newton, surface area of compression plane in square meter. Where the pressure will be greater when the surface area is getting smaller. We back to fluid pressure. Fluid have the property of compressing in all direction, meaning that for the example, if you put an object into a type of fluid, it will experience pressure in all direction. The amount of pressure exerted by the fluid depends on a depth of the object. In direct profession, the deeper the object is the greater the pressure. The pressure caused by this fluid often referred to as a hydrostatic pressure. Next is hydrostatic pressure. Hydrostatic pressure is the pressure exerted on a liquid that isn't at rest or in equilibrium due to the influence of gravity. The amount of hydrostatic pressure obtained by a substance is determined by the magnitude of gravity due to the position of depth and the density of the liquid. A small volume of fluid at a certain depth in a vessel will exert upward pressure to balance the weight of the fluid above it. For a very small volume, the stress is the same in all directions, and the weight of the fluid above the very small volume is equivalent to the pressure. With the formula is hydrostatic pressure equal density of the fluid multiply by acceleration due to the gravity multiply by height of the fluid column. With hydrostatic pressure in Pascal, density of the fluid in kilogram per cubic meter, acceleration due to the gravity in meter per square second, height of the fluid column is in meter. Okay, next. We can see the example of problem. The problem is if the density of water is 1,000 kilogram per cubic meter and the acceleration due to the gravity is 10 Newton per kilogram, the hydrostatic pressure received by the fish is that we know height is 140 centimeter minus 60 centimeter equal 80 centimeter. 80 centimeter equal 0.8 meter. And density of the fluid or density of the water is 1,000 kilogram per cubic meter. And acceleration due to the gravity is 10 Newton per kilogram. And with the formula is hydrostatic pressure equal density multiply gravity multiply height. And with the 1,000 kilogram per cubic meter multiply 10 Newton per kilogram multiply 0.8 meter. And the answer is 8,000 Newton per square meter. Okay, next. Next is atmospheric pressure and absolute pressure. Next, atmospheric pressure. pressure at a certain depth that is also influenced by atmospheric pressure, pressing the upper surface of the liquid layer. So it can be used to determine the total pressure at a certain depth in a liquid. That we can see in a picture is atmospheric pressure is the with blue arrow. Okay, the next is absolute pressure. Absolute pressure is the total pressure experienced by object or object that are in water. And the formula is absolute pressure equal atmospheric pressure plus hydrostatic pressure. And we can use the next formula is absolute pressure equal atmospheric pressure plus density of the fluid multiplied by gravity multiply height. Where why must we calculate about absolute pressure is the actual pressure. So if we do experiment and we won't get data about pressure, it is necessary to add atmospheric pressure. Okay, I think it's all from me. Thanks for your attention, and I back to the Maya Anggraini.
Okay, thank you for this video. Well, hello everyone. First, I want to introduce myself. My name is Maya Anggraini, student identification number 21130222062. Lampung University Students, Faculty of Teacher Training and Education. Study Program Physics Education. I'm from Group 9. Class B. Here, I will tell you about buoyancy and its phenomena. Okay, nice. What is the buoyancy? What is the buoyant force? The buoyant force or buoyancy is the upward force exerted by the fluid against the weight of the submerged object. And the next, Archimedes' principle. Archimedes of Syracuse faithfully discovered this principle in 212 BC for objects that float or sink. In liquids or gases, Archimedes' principle can be expressed as any object wholly or partially submerged in a fluid will always be lifted by a force equal to the weight of the fluid displaced by the object's presence. And the next, a submerged object displays a fluid equal to the volume of the object, but an object floats only partially. Archimedes' principle does not take into account the surface tension or capillarity acting on the object, but this additional force only changes the amount of fluid displaced. So the principle buoyant force is a weight of fluid displaced. Remains true. And the next, what is the Archimedes force? Archimedes force is the upward force on an object when it is immersed in a fluid, liquid, or gas. Archimedes force was discovered by a Greek scientist of the same name, Archimedes. This discovery later became the law that applies in the field of physics to this day, which we know as Archimedes law. And the next, calculating Archimedes force. To calculate the Archimedes force, you can you can use the following formula. We can see picture here about formula Archimedes force. This picture explains that Archimedes force is is equal rho multiplied G multiplied V, with the statement that Vi or Archimedes force is a buoyant force with units of Newton. And the next rule is the density of the object in kilogram per meter cubic. And the next G is gravity with units of meter per second quadrat. And V is the velocity with units of meter cubic. And the next, the state of an object when it is in a fluid. First, number one, sinking object. This situation occurs when the density of the fluid is less than the density of the object. For example, iron or steel will sink if you put it in water. And you see in the picture about sinking object. And the next, second, floating thing. This situation occurs when the density of the fluid is equal to the density of the object. For example, an egg that is put it in water with a little salt will float because the density of both is the same. And this picture explains about a floating thing. And the next, number 3, floating object. The situation occurs when the density of the fluid is greater than the density of the object. For example, styrofoam or plastic will float if you put it in water. The next is Archimedes law application. Application about Archimedes law have a 3. First, submarines, and second, air balloon, and third, sea shipboard. Okay, first, submarines. Submarines are an example of the application of Archimedes law in everyday life. Submarines are able to adjust their density in the water so they can dive, float, and float on the surface of the water. The trick is to remove or add water to reduce or increase in its density. And the second is air balloon. The application of Archimedes law also applies to hot air balloons. The air in the hot air balloon is heat so that its density becomes similar than the density of the surrounding air or atmosphere, so that the hot air balloon can float in the air. And the third, sea shipboard. Ships are usually made of steel or iron, but can float on the sea. Why is that? This is because the lifting force of the ship is proportional to the weight of the ship. Ships have a hollow ship, so that the volume of water displayed will be greater and the upward lifting force will also be greater. And the next, okay, right in the PowerPoint, you can see this picture, and the picture example about is Archimedes principle. In the first picture is a sinking object, and the second picture is floating, and the third picture is floating object. Okay, that's all I can say about buoyancy and its phenomena. So the next, I back to moderator. Thank you.
Okay, thank you, for the explain from Mayang Draini and Rizky Fridion. That's all from our group 9 will deliver by presentation materials about the fluid. And for group 10 about our material. If you have a question, you can raise hand, mute. You can unmute your microphone. The first question from who? Okay, the first question from Wina Kemalasari. For Wina Kemal, this time is yours from question.
Okay. I want ask to Anita Fitria. Please explain again.
Okay, thank you for your question, Wina Kemalasari. And for the next question from Arya Pra. I will answer your question when the all member is delivered your the question. And the second question is Arya Prasetyo. For Arya Prasetyo.
Okay, I will ask from Dion with a question. What are the factors that affect hydrostatic pressure and what is the formula?
Okay, how Arya Prasetyo? That's all. Okay, the next question from Dr. Vera Yunita. This time is yours.
Okay, I want to ask, please explain briefly the Archimedes convex material. Thank you.
Okay, thank you, Vera. From okay, thank you for group 10 for question, and our group 9 will answer that your question. And the first question from Lasari, and I am will answer. The question is, can you repeat again of the explain about the fluid? Okay, I will repeat again about the fluid. So, fluid is any substance that can flow. And the example of the fluid, there are all air and all gas. And while liquids and while of solid is not classified or not classified as fluid because they cannot flow. So the substance is the fluid. There are all liquid and all gas. And the next is fluid. Fluid is divided into two. There are static fluid and there are a dynamic fluid. And the equal of the density is measurement of the mass per volume. Measurement of the mass per volume is have the unit is kilogram per meter cubic. And the 1 kilogram per meter cubic is the 10 square minus third meter cubic. And the next is, if we want to the density, we can see with the equation about the density of the liquid multiplied of volume of the liquid. And the next is this for liquids, their substance each substance has a different density. And there are third state an object in the fluid. And the first object is fluid, the second object is drink, and the third object is sink. That's all from me, Farwina Kamalasari. How the answer?
Enough.
Enough? Okay, thank you, Wina. And the next from Arya Prasetyo will the answer Maya or Dion?
I think we will repeat again about Zoom meeting because the Zoom is 1 minute again.
Our Zoom is limit. Okay, let's read next about the presentation about the fleet. For Rizky Pridion, this time is yours from answer the question from Arya Prasetyo. For Rizky Pridion, this time is yours.
Okay, I will answer the question from Arya. And the answer is factor affecting the amount of hydrostatic pressure is the first is density of liquid. The greater the density of liquid, the greater the hydrostatic pressure. And the next factor is depth of liquid. So the hydrostatic pressure will increase as the depth of the liquid point increase. The next factor is acceleration of gravity. Hydrostatic pressure will increase as the acceleration of gravity increase. Hydrostatic pressure is gravity increase. Hydrostatic pressure will increase as the acceleration of gravity increase. Okay, the next is formula of hydrostatic pressure is hydrostatic pressure equal density of the fluid multiply acceleration due to the gravity multiply height. Okay, I think it's enough from me. How about Arya?
Okay, thanks for the answer. Good answer.
Okay, thank you for Arya and for Rizky Pridion. The next question will be answered from Maya Anggraini. The third question from Vera Yunita will be answered of Maya Anggraini. For Maya Anggraini, this time is yours.
Okay, thank you, Anita. I will answer question from Vera Yunita. The question is explained briefly the Archimedes concept material. The Archimedes concept or Archimedes law explains the relationship between gravity and the upward force or buoyancy, an object when it is immersed in a fluid. Due to the upward force or buoyancy, the object in the fluid will lose weight. Thus, objects within the fluid will feel lighter than when left on land. Archimedes' law reads, an object that is partially or completely immersed in a fluid will experience an upward force equal to the weight of the fluid displayed by the object. Well, that's all. Well, that's all my answer. What about Vera? It is enough. How about Vera?
Okay,
Okay, thank you, Maya Anggraini, for your answer.
Okay, thank you for Vera Yunita from that question, and thank you for Maya Anggraini from that answer. That is good, and I think enough from our discuss today about the material of fluids, and for my friends in here, you are in here. You are in here have a idea or have some materials others about the fluid, or enough? Enough? Okay, thank you. I think that's all. And I am Anita Fitria. I say sorry if there are mistakes in my speech word. And I say Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you everyone and good night.